Tony Echo India 5 Echo Mike here, and I'm just going to do a few additional comments there for the building of this oscillator, Morse practice oscillator. The captions should be sufficient, but sometimes I haven't included everything in the captions, so I'll run a parallel commentary. As you can see there are two transistors in the circuit. They are down as 2N3904s. Now I didn't have such transistors, but any generic NPN transistor will do in place of the 2N3904s. So I had BC548s and I substituted them into the circuit, and the circuit worked fine. So there's also an LED. You can see an LED top right, or top left I should say, and that can be done away with if you don't want the additional current use there. And you bring the top of R3, you solder the top of R3 up to the 9-volt rail, or just short out the two terminals that would accommodate the LED. And another nice addition, if you wanted to go for it, an option would be to put a push button across C3, and you could trigger the device with the push button. Now it wouldn't be the same as using a Morse key, but nonetheless it's a nice little addition to the circuit. So with that, we'll move on to the next slide, and we'll pick it up from there. Here's a list of the components, and you can see at the top there where I say I use the BC548s. If you're using any other transistors, just make sure that the pinouts correspond to the circuit as I've designed it. You might have to, in my case, the faces of the transistors of the BC548s face left, but some transistors, the collector and the base may be reversed, so you might have to have the transistor the other way around. But just download the pinout guide if you're using a different transistor. So as you can see there, I have the option included there of fitting a push button, and as I said earlier, the LED is also optional. You could short that out if you don't want to use it. And you can also pick whatever color you want for the LED. It doesn't really matter. I just used white LEDs because that's what I had. I'm too lazy to go rooting for other colors, so the whites were the first one that I came across, so I used it. So that's the list, and in the next piece I'll show the actual components themselves, so just stand by for that. Here are the components themselves side by side. I haven't included the speaker or the push button, the optional push button, but from left to right you can see the two 0.1 microfarad capacitors. I used those also because they were handy. You could use smaller capacitors as well. Ideally they should be reasonably matched for the circuit. Then the four resistors. There are two 470 ohm resistors and two 10k resistors. You can see them there in the center. To the right of those are the two transistors, or in my case BC548s. Then going right again, 10 microfarad 16 volt, at least 16 volt electrolytic capacitor. And then you see the LED, the final component on the right hand side. You'll notice on the electrolytic capacitor and also on the LED that one lead is longer than the other, and that's just convention. It's not just by accident. And by convention, the longer lead will be going to the positive end of the voltage concerned. So just be aware of that. I made a mistake actually in the circuit when I soldered in the capacitor, the 10 microfarad capacitor. I put it in the wrong way around. But I've since changed it around, so just be aware of that as well. That the capacitor that's shown in the slides, that capacitor is the wrong way around. So we leave it at that and move on to the next section. Here we have the layout. It's on a piece of board, wooden board, just something I had handy. And I'm using very, very small wood screws as the soldering points. I ordered a box of these from Amazon, and there was a few thousand of them in the box. I didn't count the number I needed, but you can see there the locations of the wood screws, and I've used a Sharpie pen there to show the joining up of the wood screws, where I will use bare wire solder to the terminals. My Sharpie pen there shows the layout there of the wires. So in this picture here, you see that the wood screws are not soldered. What I did, and you'll see in the next clip, is I tinned the top of each wood screw with solder to make them ready for the component, the required components. So let's move on. Let's leave that photograph there, and we'll move on. This is almost identical to the previous photograph, but the difference is you can see the tops, the screw heads, the wood screws have been tinned with solder, ready for components to be soldered in the appropriate places. So I won't dwell on that one too long. It's more or less self-explanatory, and we'll move on from here. This photograph shows the point-to-point wiring, and I use bare wire, and it was easy to bend around the individual screw heads. But in my haste, I forgot one of the links. You can see it there outlined in yellow. It goes from the base of the second transistor, TR2. So when I switched on initially, there was nothing happening, just the LED came on. So backtracking, I just found that link was missing. So once I installed it, everything worked out okay. I think otherwise the photograph is self-explanatory, so I don't think I need to make any further comment on that. This photograph is self-explanatory as well. It just shows the locations of the different components on the board and the external connections. You will notice there C1 bridges across the wiring from the base of TR1, so make sure that it's clear It stands a little bit above the board. The speaker connects to the two top right terminals, and you can see where the key in the battery connects. And you can see on top right, or top left I should say, you can see short leads, and that refers to the electrolytic capacitor and the LED. Their short leads will solder to the top rail. Just be aware of that there, and that's about it. Have a good look at the layout, and you can see where the battery negative connect well. The second parallel trace from the bottom. There's any of the three screw heads there. You can solder the battery negative to that. So that's the outline, and in the next one, I'm not going to go component by component for construction. I'll just show the completed project. So that's it. This shows the components wired up and the completed project. You can see the point-to-point wiring there with the bare wires. And the thing to note there as well is the bridging from the collector of TR1 across the trace from the base. Make sure that's well clear. The two speaker connectors are up the top right, and you can see the battery connector top left along with the key connector. And as I said, you could also fit a push button across C3, and you could glue it or some way attach it to the board to make it nice to be able to send Morse by pressing the push button. It wouldn't sound as well as with the Morse key, but a nice little option nonetheless. So that's the completed project. The next one will be to show you the oscillator in action with a key connected and with the loudspeaker connected.